Hi, my YouTube viewers. Crystal here. This is going to be my third video that I've made on this subject because I had a screen recorder in my Google apps and I was in the middle of recording and the screen recorder just disappeared. Honestly, I don't know what happened. So I tried to make this video this morning and I made a mistake, so I stopped. And then for the last half hour, I was making the video. And then when I tried to stop it, it would not allow me to stop it. And that's when I found out that the actual screen recorder has been removed from my computer. So now I'm trying to use an online screen recorder. So this is number 3. I should be pretty good at giving this presentation since it's the third time I've given it. What I want to do is I wanted to give you my solution to Kaggle's identify the disaster competition question. So this was my solution. You can see that I submitted it to Kaggle and I got an outcome of 72847 on it. I had other shall we say, entries that were higher, but they were not really my own work. They were just work that I borrowed off other people. But this was my own work. This was something that I did myself, so I can share this with you as being my own work. I've also shared this notebook, so you can look at the notebook while you're watching the video if you want to go along with me. So the first thing we're going to do is we're going to talk about the competition description. Twitter has become an important communication channel in times of emergency. The ubiquitousness of smartphones enables people to announce an emergency they're observing in real time. Because of this, more agencies are interested in programmatically monitoring Twitter, i.e., disaster relief organizations and news agencies. But it's not always clear whether a person's words are actually announcing a disaster. This dataset was created by the company Figure 8 and originally shared on their Data for Everyone website here. So the first thing I did was I imported my libraries, and you can see that I've imported my libraries. The second thing I did was I imported the files that I would be using. They were training files, testing files, and sample submission files. The next thing I did, that was number 3, is I loaded the files. So you had your train file, test file, and your sample submission. Number 4, I checked the shape of the train file and test file. You'll see that the train file had 5 columns, whereas the test file had 4 columns. The reason why the train file has 5 columns is because the train file has the target column, and the target column is the dependent variable, and the other columns are independent variables. And we have to predict upon the test file. And so that's why we don't have the target column on the test file. The next thing we're going to do is we're going to impute any null values. So we put some code in to ask if there were any null characters, and you can see keyword and location columns both had null values. The next thing we did was we imputed those null values. Since the keyword and location were object files, we were not able to use median, and we were also not able to use k nearest neighbor, so I just used mode. And what mode is mode was the most frequently used answer. So in step number 7, I asked again if there were any null characters, and no, there were not any null characters. Step number 8, we went to check the shape of our train file and our test file, and you can see the shape is still the way it had been previously before we imputed those variables. Now what we do is we've got a little chart where the test file is compared to the train file, and you can see that there were less tweets in the test file than there were in the train file. And now what we're doing is we're just checking the percentage of the disaster tweets opposed to the non-disaster tweets. So you had 3271 tweets that were number one, which meant it was a disaster, and 4342 tweets of number zero, which meant that it was not a disaster. So we checked it again, and this time we checked in the percentages, and so 57% of the tweets were not a disaster, and 43% of the tweets were a disaster. So we just asked the same question again in a different format. And now what we have is a graphical representation of the tweets, whereas you have significantly more tweets that were not a disaster than you do tweets that were a disaster. So now what we have to do is we have to pre-process our text. So what we did was we imported our HTML parser. And then the next thing on number 15, we created a new column called process text, and all of the text processing was going to go into this column that said process text. I got an apostrophe dictionary from somewhere, and I used that. I put that into my program. And then so what we did is we used a function called lookupdict, where all of the words that had apostrophes in them, we put like the regular words in it. So we replaced all of the apostrophes with the fully spelled out words using this line of code in number 18. So then what I did was I got a hold of a short word dictionary, and this is just what people will put in tweets, and I replaced all of the short words with what they should have been written out. Then I got emoticon dictionary that says either happy or sad, and I replaced the emoticons with the words either happy or sad. Now what we did was we imported this function called RE, and that's necessary for natural language processing. We imported in LTK, that's natural language toolkits, so that's necessary for language processing as well. So we imported our stop words, and we imported Porter Stemmer. So what the stop words were was they wanted to remove all of the stop words from the tweets because they didn't have any meaning. And then what Porter Stemmer does is Porter Stemmer just like chops off the last part of the word. So because the idea is it's just too much for the computer to have to contend with. So what it does is it just deals with the basic meaning of the word instead of the entire word. And so that's why when you look at the text, you notice that quite often the last part of the word has been chopped off. And that's the work of the Porter Stemmer. Now what we've done is we've imported string, and we've done some more text processing. We made all the tweets lowercase. We removed punctuation from the tweets. We removed hashtags from the tweets, and we removed any words that were less than 3 characters. And then what we did now is we just developed a mosaic of all of the words by using a word cloud. And this is a mosaic of the 50 most common words in the tweets. So what we did now is removed all the rare words. We've got this coding in here. So every word that appeared only once, we removed that because the computer was not going to be able to train on that word if it appeared in the columns only once. So it was removed for that purpose. We looked at our train file after we had all of this data processing done, and we looked at the test file as well, and you can see that the last end of a lot of the words have been chopped off. Now what we do is we define our X, Y, and X test, and so Y is train target. Y is your dependent variable, and it's dependent upon what's going on in X. And X is train process text, and X test is test process text. So we're going to split our training set into X train, X val, Y train, Y val using the train test split with X, Y, stratify equals yes, test size equals 0.1, random state equals 42, and shuffle equals true. We wanted to see the shape of these files after we've split the file up, so you can see the shape of X train, X val, Y train, Y val, and you notice that they're only one-dimensional arrays. Now what we have done is we're going to convert the text to word frequency vectors. So this is the coding to convert the text to word frequency vectors. And so train TF-IDF is derived from X train, and val TF-IDF is derived from X val. X test TD-IDF is derived from X test. So we wanted to see the shape of train TF-IDF, val TF-IDF, and X test TF-IDF, and you can see now they have 4530 columns, whereas before it was put through the vectorizer, it was just a one-dimensional array. So now what we do is we define our model. And so in this instance, I use XGBClassifier because I had a choice between MLPC classifier and XGBClassifier, but I got a higher rating from XGBClassifier. So I decided to use that in the end. So model equals XGBClassifier, which we fit using train, TF-IDF, and Y train. And then we set our hyperparameters, and we used the grid search CV, and we decided on best model, and we got a 97.68% accuracy on train, TF-IDF, and Y train. So now what we've done is we've tested on val TF-IDF, and we got a 76.64% accuracy. So that's about a 21 points lower than the accuracy of X train TF-IDF. So that just means that it's more difficult to make predictions on text files than it is numeric files. So we did some more data processing on this outcome, and we put the output on a data frame. So you can look at the data frame and you can compare the actual value to the predicted value. So we did the same thing to X test TF-IDF that we did to X val. We predicted on that. And you can see we had to do a little bit of work on that as well to convert it to an integer. And we made a data frame. We turned it into a data frame of ID and target, and we converted that to a submission file, which we submitted to Kaggle. And when I submitted that to Kaggle, I got a 72847 percentile, 72.85% on that. So I know it's not fantastic, but it's my own work. So I can say, well, yes, it is my own work, and which it will get you on the leaderboard. And I think I did it in a logical fashion. And then I explained what I was doing as I was doing it because I used my text coding so you could see everything I did. So that completes my presentation for the Kaggle Identify the Disaster Competition question. And let me know what you think. If you have any comments, please let me know. This Jupyter Notebook has been made public so people can look at it. I mean, I've noticed now it's had 31 views so far since I made it public 7 hours ago. And if you like my work, please like, subscribe, and share. If you want to make a donation, I've got my email address to my PayPal account in the description. And the reason why is because I don't have enough subscribers to be able to monetize my channel. And that's why I have to ask for donations. But thank you so much for watching this video, and I look forward to making a new one for you as well.